Alright guys, today the question we'll be solving is regarding the meridian passage of a star. Meridian passage questions are also called latitude by meridian altitude. My previous video was about calculating the meridian passage or latitude using the meridian passage of a sun. I'll provide you with a link with this video as well. But this video is about calculating the latitude or the observed latitude using the meridian altitude of a star. So that means obtaining the meridian altitude when the star is exactly on the observer's meridian. Alright, that is the time of meridian passage. Meridian passage time refers to the time when the celestial body in its transit from east to west is exactly on the observer's meridian. So let's get into the question. The question says that it's 1st of December 1992. It's AM, and that means it's morning at ship in DR position or dead reckoning position, 45 degree 20 minutes south and 75 degrees east. And the sextant meridian altitude of the star Procyon, Procyon is the name of the star, was 39 degrees 28.8, and index error was 1.5 minutes off the arc. Height of eye was 25 meters, and what you have to do is find the latitude. This is called the observed latitude, and the position line, also known as PL. Alright, so it's a pretty straightforward question. The tricky part comes later. I'll show you what I mean by that. Alright, so let's start solving the sextant altitude. So sextant altitude was 39 degrees 28.8 minutes as given to us in the question. Index error is off the arc, that means I will add the index error. If it was on the arc, I will subtract it. But if it's off the arc, I have added 1.5 minutes to the sextant altitude, and I got my observed altitude as 39 degrees 30.3. Then I obtain my height of eye correction for 25 meters, which is also called dip. Right, to do that I have to go into the almanac. So I go into the almanac for dip of so I'll come back to this page later. I need this page here. Alright, so height of eye and dip correction is here, height of eye is here, meters is here, and feet is here. So for a height of eye of 25 meters will be somewhere here. You can see here between 24 and 26, so no interpolation. So for 25 meters it will be minus 8.8 or something, right? So I have obtained minus 8.8 here. Alright, so if you didn't get what I did, I'll go back again, and you can see that for 24 meters it's 8.6, and for 26 it's minus 9. So 25 will be somewhere in the middle, and the middle value will be minus 8.8 somewhere here. Right, that's what I did. So I get a height of eye of minus 8.8. And a height of eye correction is always negative, so I'll subtract it, and then I get my apparent altitude of 39 degrees 21.5 minutes. With this apparent altitude I have to obtain my total correction. So I'll go back to the nautical almanac and this is the place I get my total correction from for stars and planets. So this is a star, so my apparent altitude was 39 degrees 25 minutes or something. It will be somewhere here in the middle of 37, 45 and 40 or 6. So my correction would be minus 1.2. Right, so this page is normally the third page or fourth page of your nautical almanac. At the very beginning of the nautical almanac, you can go into the nautical almanac and find this page. So minus 1.2 is the total correction. I apply the total correction and I get my true altitude of 39 degrees 20.3 minutes. And then I have named it north because it says that it should be named same as bearing. Now what does that mean is that the celestial body is now on my meridian, but I don't know whether it's north of me or south of me. So I'll figure that out by drawing a portion of the rational horizon diagram. So what I do is I draw a vertical line because I know that the celestial body is somewhere on my meridian. I will draw the celestial equator as a reference point, which is Q, or it's also called equinoctial. Then I plot my DR latitude, which is 45 degrees 20 minutes south. So I will go south of the celestial equator because I'm south, and I call it Z. This is the observer's zenith. Right, this one here is the equator, or rather celestial equator or equinoctial. Right, and then I plot my celestial body's declination. The declination is 5 degrees and 14.6 minutes north. Now where did I get this declination from? I'll go back into the almanac, and for 1st of December 1992. So what I do is I'll go back to the almanac, and for 1st of December, let me find out for 1st of December. So this is 8th, 9th. So somewhere here is 1st of December, and you can see here these are the stars here, right? So for Procyon, my declination is 5 degrees 14.6 minutes north. So I have used that declination here. Right, so it's north, so I will go north of the equator, and I will call myself X, or rather the celestial body is denoted as X. So then you can see that the body is bearing north of me. The celestial body is bearing north of the observer's zenith. And that's why when I'm naming my true altitude, I will name it north, because it's named same as bearing. Then I will subtract the true altitude from 90 degree and get my MZD, or meridional zenith distance. Because it's a case of a meridian passage, it's called MZD or MZX, or meridional zenith distance. Otherwise it's called true zenith distance, or TZX or TZD. I get this by subtracting the true altitude from 90 degrees. Once I get the value of 50 degrees 39.7, I have named it south, because this is always named opposite to true altitude. So because I have named my true altitude north, I will name it opposite to the true altitude, which is south. Then I write down the declination that I got from my nautical almanac, which is 5 degrees 14.6 minutes north. The rule here is, if they are different names, in this case they are different names, one is south, one is north, I am comparing MZD with declination. If they are different names, you will subtract it, and you will retain the name of the larger. So that means you will name the latitude according to the name of the larger, which in this case is MZD, which is south. That's why I named it south. This south comes from here, and I will subtract to the declination from the MZD and get my observed latitude. That's the answer. 45 degrees 25.1 minutes south is the answer, which is different from the DR latitude given to you, but close to it, but different. Now when it comes to Meridian Passage, position line is always east or west. That's because the body is bearing north or south of you, it's vertically, and perpendicular line to the bearing is always east or west. So even if it was bearing south, perpendicular line to that will always be east or west bearing. That's why position line in case of Meridian Passage is always bearing east-west. That means it's bearing 090 to 270. This is in case of all Meridian Passage questions. The tricky part here is that if you are required to calculate the time of the Meridian Passage. Now remember, with sun, in the case of sun, or if you have seen the video, and if you have not, then you please watch the video, and you will see that with sun's case, the Meridian Passage time, or the LMT, or the local mean time of the Meridian Passage, is actually given to us in the almanac. I can show that to you what I mean. So if you go back into the almanac, you can see here that the Meridian Passage of the sun is given to you here for the different dates. This is the LMT time, local mean time, and then you can apply the LIT, or longitudinal time correction, and get your GMT. Alright, even for planets the approximate time is given here, but with stars there is no time given for Meridian Passage. So what do you do? So you basically work backwards. So now you know that LHS star is basically a combination of GH Aries, SHS star, and longitude east. Alright, now at Meridian Passage of star, the LHS star is equal to 360 degrees. The LHA is 360 degrees because the celestial body is exactly on the observer's meridian, and LHA is basically measured westwardly from observer to the body. It's exactly 360 degrees. Alright, so therefore this means from this formula here, LHA 360 degrees will be equal to GH Aries plus SHS star and longitude. Now on 1st December, what is the SHS star that I can get? So on 1st of December, the SHS star of Procyon is 245.15.5, because we are talking about 1st of December, right? That was the date given to us in the question. So I use this SHS star, and I put this here. The longitude is also given to me. Once I have 2 out of the 3 values, I can just add them and then take them onto the other side here and get my GH Aries by subtracting it from 360, and my GH Aries is 03944.5. This is my approximate GH Aries when the Meridian Passage is occurring. Using this Meridian Passage or using this GH Aries, sorry, I'll go back into the 1st of December and see where at what time is this GH Aries occurring on the hermetical almanac. So GH Aries is the value is 39 degrees 44.5. So the closest I can come for GH Aries for 1st of December here is somewhere here 2100 hours when it is 2557.9, because after that it's 41 degrees. Alright, that's more than the GHI required. So the closest I come is here at 2100 hours for at the value of 25 degrees 57.9. So I go back here and you can see that for GHA Aries for 2100 hours is 25 degrees 57.9. The next star that would have been 41, which would have been more than the GH Aries. So I subtract the GHA Aries from 39 degrees 44.5 and I subtract the GH Aries for 2100 hours. That gives me a remaining of 13 degrees 46.6 minutes, which I should find in the increment section. So if I go into the increment section for the stars, and you'll have to work it out a little bit, you can't find it straight off. In this case here I'm giving you the value straight off, but in your case you'll have to just go and search through, you have to go through the different minutes and find out where is this occurring, and with some patience you will see that it goes and occurs at 54 minutes and 57 seconds. So again this page here is not been scanned properly. So if you go into the that reminds me to scan this under this GH Aries and this increment of 54 minutes. If you go down here somewhere at 57 minutes here, this is 57, 13 degrees and 46.5 is what you need, right? Somewhere very close to that. So 13 degrees 46.6 you need, somewhere around that 54, 57, you get it at 54, 57. That means your GMT Marpas becomes 1st of December or 1st of December. Is that right? 1st of December? 1st of December, that's right. 1st of December at 2100 hours 54 minutes and 57 seconds. But if you apply your LIT east, that is your longitude in time, how do you get your longitude in time? By dividing your longitude by 15. In this case, if you divided 75 degree by 15, you get 5 hours, which is plus 5 in this case, because if it's east longitude you are ahead of GMT. So that's why I add my LIT to the GMT time to get my local mean time. But when I do that, when I add 5 hours to 21, 54, 57, I actually go into the next day. So the local mean time on my ship is actually on the 2nd of December, not on the 1st of December. But the question says it's 1st of December 1992 AM, it's on AM on the ship. So it cannot be the correct GMT time. So what do I do? Once I see that I'm on the next day instead of the previous day, I will subtract 23 hours 56 minutes and 4 seconds from the LMT to make it the previous day. This amount is equal to 1 sidereal day. Sidereal day is for the stars. So how do you do that? You will take this LMT and put here, add 24 hours to it to make it a bigger number, and then subtract the sidereal day from it. Once you subtract the sidereal day, this is what you get. You go back 1 day. Then this becomes your new LMT time. And this is for 1st of December. Alright, because by our calculation, the LMT was coming on the 2nd of December if GMT was first 21:54:57. So I had to subtract 1 sidereal day to make it the previous day. So when I get my LMT here as 1st of 2 hours 58 minutes 53 seconds, I can see it's AM. I can also see it's 1st of December. Then I subtract my LIT in this case because now I'm going backwards. I subtract my LIT of 5 hours because it's longitude east, GMT will be least, GMT will be lesser than my local mean time. When I subtract 5 hours, I go back onto the previous day. So then GMT Meridian Passage is 30th of November 2100 hours 58 minutes 53 seconds. So this is a bit of a tricky part in this question, otherwise the question is straightforward. Now remember, this question didn't ask you to calculate the time of the meridian passage of the star, but if it is required, then this is the way to go about it. So watch this again, go through it slowly, and you will realize what I am doing here. Otherwise most of the questions for stars meridian passage do not require you to calculate time, but if it is required, then this is the way to do it. Alright, with sun and planets it's more straightforward, as you would have seen in one of my videos, and you will see in my future videos again when I calculate the meridian passage of the planet. Alright, so hope this video was easy to understand. Again, I thank you to all my subscribers and for watching my videos and subscribing to it and sending me their comments and feedback. I really appreciate it. I'll see you soon with my next video.